All right. Good evening, everyone. All of you who are gathered here, and also our online friends. Really appreciate you taking the time to come here. We are excited to do this in partnership with Carnegie Library. Really thank all of their efforts in helping us, put this together. So this is a series of 4 events, spread out probably like 2 weeks to 3 weeks, something like that. We really wanted this, maybe just to set the context, and when I say we, I mean the AI Institute for Societal Decision Making. So we are the National Science Foundation funded institute that started last year. It's funded for 5 years, and it's really a multi-university initiative led by Carnegie Mellon.
And we have as partners Harvard University, Howard University, Navajo Tech, Texas A&M, the Pennsylvania State University, the University of Washington, Boston Children's Hospital, and a local high school, Winchester Thurston.
Yep, so we are a spread out group. But one thing we were hoping to achieve is, of course, we are doing the research and also developing some educational programs like degrees and undergrad, minors, Rebecca, specific that effort, around using AI to help with decision making, particularly in societal context. So things like maternal health is a big topic that we are looking at. How can we identify pregnant women who are at risk using AI, working with their data, and help drive interventions that can keep them engaged with health services, target them with like sending out community workers to, talk to them, or just send personalized messaging. We are also looking at similar issues in disaster management or emergency management, more broadly speaking, where we are looking at how AI can be used to train people, helping out with disasters. Can it make recommendations about how to allocate resources while ensuring not only timeliness but also equity of the resource allocation. So that's just a sampling, but we really wanted to, in addition to the research and education pieces, connect with the public, right? And understand, maybe create a little bit awareness of AI, but really understand what your perspectives are and how we can take that into account in the work that we do. So I imagine this not to be a lecture series, but really a participatory dialogue where we really want to hear from all of you. So please ask questions. I hope this is just an engagement where you can speak your opinions and or questions and doubts. I know there's a lot of hype and here about AI, and we hope to be able to connect with you on that, both to help us in guide our efforts in making it more approachable, but also from your own perspectives. Getting a sense of what that is. Okay, with that, I'll actually hand over to Norm, who's done a lot of the work in putting this together. So Norm is the Managing Director at the AISTM, and I'll let him introduce today's topic and speaker.
Thanks, Artie. I just want to express my gratitude to the team here at the Carnegie Library for helping us put this all together, to put together the speaker series. It's been a real pleasure working with you, and we've got a great lineup starting with today. So we have with us today Dr. Roni Rosenfeld, and he's a professor of machine learning, language technologies, computer science, and computational biology in the School of Computer Science at Carnegie Mellon. He's taught machine learning and statistical modeling to thousands of undergraduate and graduate students since 1997, and he's been a mentor to 5 postdoctoral researchers and an advisor to dozens of PhD students. Many masters and undergraduate students as well. In addition, from 2018 to 2024, he served as the head of the machine learning department, and his current research interests are in tracking and forecasting epidemics. He heads up the Delphi Research Group at Carnegie Mellon, which he co-founded and has co-led since 2012. And that group has been playing a leading role in the development of epidemic forecasting technology in the US. And it's been named the National Center for Epidemic Forecasting of the US Center for Disease Control. So Roni has previously worked in statistical language modeling, speech recognition, human-machine interfaces, and the use of speech and language technologies to aid international developments. And he's published a bevy of scientific articles in academic journals and peer-reviewed conferences. He's a recipient of the Spira Teaching Excellence Award and is twice the recipient of the Alan Newell Medal for Research Excellence. So he's kicking off our series here with the introductory talk on artificial intelligence and generative AI, titled The Past, Present, and Future of AI, Historical Perspectives and Shameless Predictions. Please join me in welcoming Dr. Rosenfeld.
Thank you. Thank you very much. So this is a small enough crowd that I can maybe get you to talk to. I don't like to talk to people, I like to talk with people. So I would very much appreciate your participation. Please interrupt me early and often. Okay? Let me tell, I have slides, I have about 10 slides. They talk a little bit about the history of AI starting in the 40s, decade by decade, up till today, then talk a little bit about what's the new and exciting thing that's happened in the last 5 to 10 years, and then about the implications, societal implications as I see them, the good and the bad and the dangerous. I usually start at the beginning and don't get past the second slide. So if your interest is at the end, let me know and I will start at the end or at least run through the beginning. But my main goal is to do what you would like me to do. And for that, I really need to hear from you. If you do this, then I know I should fast forward. If you interrupt me and ask questions, then I know my time is well spent. Okay? All right, I love history. So let me start with the first slide. That's history. Does this work? Nope.
Try it now.
Now it works. Okay, so here's a brief history of artificial intelligence. Computers, modern digital computers started in the 1940s, right during World War II and a little bit after it. And at the time, if you asked a layperson in the street what computers are, if they heard about them, these are these things that can calculate, they could add and multiply numbers very, very fast. So people thought about it as a mathematical device, something that does calculations very fast. It didn't take very long to realize that computers actually do a lot more than calculate numbers. They can represent logic. So you can think of what they do as manipulating numbers, but you can also think of what they do as manipulating bits, just ones and zeros. And they can do ands and ors, and they can simulate other systems. So you can write today a computer program that would simulate what happens when a mountain erupts, or in human society, or any process that you can think about and write down in an organized way. You can write code that was simulated. And if you're familiar with computer games, these are all simulations of people driving crazily and crashing into each other. Right? These are all simulations. So computers are simulators. In fact, the math that they do, they're simulating the kind of math that we do in our head or on paper. So the main thing they do is simulate rather than calculate numbers. Now, there was a very important proof or conjecture in the 1950s called the Turing hypothesis that said that computers can simulate anything. Now that's a very vague statement. It's not very well defined. And the Turing hypothesis itself was not that well defined, but it basically said that anything that you can put together a mechanical system that would simulate, you could do with any kind of computer. So it doesn't matter whether you build a computer out of modern chips, or out of Lego pieces, or out of wood pieces. It doesn't matter how you represent it. As long as it can do the basic things that computers do, it can simulate as well as anything else in principle. That was a big sort of conceptual way of thinking about it. Oh, computers can do anything. Well, what's the most exciting things they can do? Well, they can maybe simulate how people think. Okay? And there came the idea of artificial intelligence. There was a particular time when that was born, 1956. There was a conference at Dartmouth University where a bunch of people who worked with computers came together to talk about the possibility of computers one day simulating the way people think. And they coined the term artificial intelligence. Interesting who was at that conference. One professor from MIT called Marvin Minsky, he went back and established the AI department or lab at MIT, which became a big center of AI. One professor from Stanford, John McCarthy, went back to Stanford and established a very large AI presence there. Two people, Alan Newell and Herb Simon, who came from Carnegie Mellon University, then a very small, it was Carnegie Tech, a very small place that nobody has heard of. So the four main founders of AI, two of them came from CMU, which goes a long way to explaining why CMU has become such a center for AI. It's called the founders effect, you know. It's when the field is very small, where the few people that are in the field go determines where things are going to grow. So we have that to thank them for. So they came back the mid-50s, and in the early 60s, please.
Yeah, was Ada Lovelace, was she trying to tell us about?
Oh, she absolutely was. Now we're talking about the history of computing.
I don't think she was there.
No. She was in the 1800s, I believe.
I think she died in 1857.
Okay, there you go. And before her, Charles Babbage.
Well,
So
they were kind of ran around together.
I should add them here, right? And I did that. When I gave a talk to Girls of Steel, I started with Ada Lovelace. Fair point. We started there. Let me move back to the 60s, a period of tremendous optimism in general in society, huge economic growth. Science made huge progress, and a lot of optimism about AI. If you go back to newspaper articles from the 60s about artificial intelligence, they talked about how it's right around the corner. Scientists are working on getting computers to translate from one language to another. We'll update you next week how it's going. Scientists are working on recognizing speech from a microphone and transcribing it automatically. There were movies that were showing examples of that. And scientists were working on that, but it wasn't going very well. They continued to work on that in the 70s, but the sad reality is that the attempt to solve AI, to build computers that do things like people, wasn't going very well in the 60s and 70s. To understand why, we need to talk about two kinds of AI, or two approaches to AI. The approach that was tried first in the 60s and 70s is what I called knowledge-based AI. Knowledge-based AI is the idea that if you want to translate from one language to another using a computer, the first thing you need to do is ask yourself, how do people translate? So go and talk to a professional translator who translates, let's say, from English to French, and ask them to explain to you how they translated. And then you listen to them for a long time, you take notes, and then you try to simulate that in a computer. Same thing if you try to do other things that people are good at. If you want to recognize speech, you go and talk to phoneticians and grammaticians and linguists of different types. You talk to people who understand how microphones work and how sound bounces off different areas. You go to the domain experts and you interview them. And you say, how do you think people, and domain experts in this case includes neurologists who study how sound goes through our ears and our cochlea and into our brain. And you try to understand the domain as best you can and then go and convert that into a simulation by a computer. One more example, if you want to write a computer program that would be as good as a human doctor, what do doctors do? Many of them listen to your complaints, examine you, take various measurements, blood tests, bring this all back together and make a diagnosis of what the problem is. And then there's a second part of how to treat the problem. But if you focus on the diagnosis part, if you want to write a computer program that would be able to diagnose people based on their symptoms, start by talking to doctors. That makes perfect sense, right? And you have to talk to a lot of doctors, and you have to talk to them for a long time, and you have to write down what they do, the process they go through, and what rules they use. And that's exactly what they did in the 60s and 70s. And when they build these systems, some of you are old enough to may remember that term, expert systems. Anybody? In the 70s, expert systems were all the rage. What expert system meant was a computer program that embeds a large number of rules that were derived from talking to experts. So you interviewed dozens of doctors for hundreds of hours, you converted their wisdom into a set of rules, you wrote these rules down in computer code, and then in comes a new patient, you feed in their symptoms, you follow the rules that the experts told you about, and out should come your diagnosis, okay? That was the plan. Didn't work very well. As long as you were dealing with patients that these doctors have seen already, it was working more or less okay. But once new patients came in, the rules just weren't right. And this brought us to one of the, I think, most important realizations that was missing up until the 70s or 80s, is that sometimes we know, so go back, the doctors cooperated, they did the best they could, but the rules they gave were not complete. And often you brought them a case where you followed the rules and the answer was not right, and they said, oh yeah, of course it's not right, because in this case you shouldn't have done this, you should have done that. And you ask them, why didn't you tell me that? And they said, well, I didn't think about it at the time. So what's the take-home message from all of that? Is that sometimes people know how to do things, but they don't know how they know it, right? So doctors are better at making diagnoses than at explaining how they make diagnoses. And that's true in every field. A translator from one language to another is better at translating than at explaining to you how to do translating. A child is better at riding a bike than explaining to you how to ride a bike, okay? And that's true in many, many areas of human endeavor, that being able to do something is not the same as understanding how you do it, let alone being able to explain how you do it. In hindsight, that is probably the main reason this approach to AI did not work very well. It took us a good 20 years to come to that conclusion, but from the early 60s, which was very optimistic, till the early 80s, which people were kind of tired of AI and it wasn't going anywhere and we got less funding, was the period of knowledge-based AI. Sometime in the early 80s, somebody suggested a somewhat different approach. Forget about talking to experts. Experts don't know what they're talking about. Or maybe they do know, but they think they know, but they don't know as well as they think. Or they're not good at explaining it to us. It just doesn't work. Forget about experts. Give me examples. Instead of talking to 20 doctors, just collect for me thousands of files, or maybe better, tens of thousands or hundreds of thousands of medical records. Have somebody code all the symptoms for each record and what the diagnosis is. Another one, symptoms, diagnosis, symptom, diagnosis. Do that 100,000 times, very tiring, much more tiring than interviewing doctors. But do that, maybe spread it among many people. And now you have 100,000 examples, or what we called in the field labeled examples. Labeled examples means examples with the correct answer. The word label here means the correct answer. And now we have a function. What is a function? A function is a mapping from input to output. So now we have some kind of function that maps, or we want to derive a function that maps a set of symptoms to the correct diagnosis. And we have lots of examples of that. And the challenge now becomes, how do you find a function that maps each one of those example symptoms to the right answer? And if you're able to find such a function, what makes you think that it will do well on the next patient, the one whose example was not included in your training? That became the paradigm for the new AI. I call that new AI example-based AI, as opposed to knowledge-based AI. The rest of the world calls it machine learning. So if you hear the term machine learning, it basically means the second way to approach AI, since the first way didn't work. It's the second attempt. It was started in the 80s, and it was far more successful, which is a very humbling experience, because we pride ourselves on our smarts and on our, experts, and we think we understand how things work, but when we try to code what we understand, it doesn't work in practice. But when we instead just take hundreds of thousands or millions of examples and come up with a rule that would map the examples, that seems to work much better. So it's technologically great, we made progress, but scientifically it's actually quite disappointing. Because if we got this to work, if we had gotten this to work, the knowledge-based AI, we would have had something in our hands that we understand how it works, because we coded the rules in it. But since we didn't get it to work, and what we got to work is an example-based AI, or machine learning, what we have in our hands is a statistical black box that in come examples and out comes rules. And the rules that come out are not rules that make sense to us. They're just rules that capture the behavior of the data. I think it's fair to say that in the next 20, 30 years, 80s and through the first decade of the 21st century, was all about making this method work better and better. It was all about collecting examples of data, labeled examples, input, output, and coming up with statistical methods that will find a rule that explains this data, that maps the input to the associated output. And then testing it on new data that was not part of the training. So we have this paradigm, this way of working in machine learning, that the first thing you do is you collect labeled data, and then you take some of it and keep it aside for testing, and you take the rest, call it the training data, and you run a statistical engine on it to tune the mapping from the input to the output, and then you keep your fingers crossed and test it on the test data. Worked quite well, much better than in the 60s. In many areas, it got close to human performance, human level of performance in many areas of AI, and in some areas it exceeded it. That brings us to about 10, 20 years ago. This method got particularly good in the last 10, 15 years. You may remember seeing in the news that machine learning programs got to play chess better than the best chess player, and played Go better than the best Go player, and solved the protein folding problem better than any method that exists before them. There was a sequence of progression in 2000, 2005, 2010, where the methods for doing that were perfected, the amount of data available for training grew, and more problems were solved. Things were moving really, really fast, and then they got really crazy. We'll get to that in a minute. But they were really, really fast already starting in 2000 and up to, let's say, 2015. If you stick with this mode of working of AI, the important things to know about is that it can do amazing things with enough examples, but it does require millions of labeled examples. And the other thing about it is that every problem that you're trying to solve that is like human-like, translation, classifying patients, investing in a stock market, anything that humans use their brains to do, you need to treat it as a separate problem. Means you have to collect millions of training examples specifically for that problem. If you trained a machine learning problem to diagnose patients, then it will diagnose patients very well, but it will not tell you anything about how to play chess or how to translate languages or how to have a conversation with someone or any of that. So it was artificial intelligence, yes, but it was artificial narrow intelligence. It was one particular task, one particular system for one particular task. And you need to have lots of data for each task separately. At that point, people started dreaming bigger. Can we build a system that would be trained once and be able to do many things, or all of these things? We know it's possible because we have systems like that here, right? We do that. We are trained more or less once in our childhood, and then we have general capability to pick up things very, very fast. So we know it should be possible, but how do you do that? The methodology that we use up until 2010, 2015 was not good enough for that. Let me go back. What we need in order to build an artificial general intelligence, not something that's narrow to a particular topic, is some form of universal representation of meaning. Representation of meaning is not new in computer science and in AI. In the 50s and 60s, if you wanted to represent the sentence, Mary ate an apple, then what scientists at the time did is they literally had a little circle for Mary, a little circle for ate, and a little circle for apple. That's a representation, but it's not a very useful representation because it doesn't carry all the meaning of these words. What you want is somehow represent language and other facts in the world in a way that is interconnected. If I say apple, it should be similar to representation of pear. If I say 8, it should be similar to representation of drink. If you have a universal representation, then many problems can be mapped into the same domain. The problem is a bit of a chicken and egg. How do you get to universal representation? It happens miraculously in our brains as we are born and grow up. We develop representations in our brain. We kind of know where in the brain, what parts they are, but we have no idea beyond that. It was one of the most difficult stumbling blocks in AI in general, is how do you build useful representations? The notion of useful representation is strongly connected to a bottleneck of information. Why is that? If I'm trying to send you a message from far away, and I have to send you the message through a very narrow pathway, so I can only send you a few bits or a few words, I'm going to choose my words very carefully. If I cannot just blabber at you whatever I want, I only have a few words to convey a lot of meaning, the words I will choose will be meaningful, thoughtful, and well connected to each other. We use this principle in AI to build representations by forcing them to pass through a bottleneck of information. So imagine that you're trying to map not symptoms to patients, but symptoms to the same symptoms. You have a list of symptoms as your input, and you want the same list of symptoms as output. That seems silly. You know, that there's nothing to learn here, right? You're mapping something to itself, but now I'm putting a condition on you. You cannot list all these symptoms. You can only send one word in between them. So the symptom is you're thirsty, you need to pee a lot, you have numbing in your feet, and you don't feel well after you eat sugar. 4 symptoms. How am I going to send that through to the other side to be recreated using a single word? The word will be diabetes. Okay? So by forcing you to represent something complex with a few words, I'm forcing you to use things that are meaningful from which you can reconstruct the full list. Okay? This is the principle behind a lot of building of internal representations in AI. Now let me show you a breakthrough that happened about 5 years ago, which allowed us to build very, very powerful representations, in some sense similar to the ones that we have in our brains. So the task that we use for that is very similar to the one I just mentioned to you, but it's not given a list of symptoms, produce the same symptoms. Is given a sequence of words, guess what the next word is. Not a very useful task by itself, but it has the advantage that if you're trying to teach a system to guess what the next word would be, you're forcing the system to develop an internal representation that makes meaning of what it read before. If you were just memorizing a long list of sentences and what the next word is, you're not going to be able to generalize it to new sentences. But if you're representing whole parts of a book in a condensed way, and your goal, or rather, if you're trying to correctly predict the next word, the best way to do that is to represent the past of what you read so far, the part that you read so far, in a very compact way. This looks like magic. It feels like magic to me because I would not have believed if somebody told me that this is what would result, I would not have believed it. So in some sense it was surprising to me and to other, I would say to most people in the field. But the end result is that we were able to build a universal representation for English. I say we, I have nothing to do with that. But the field was able to build a universal representation of English from text, from large amounts of text, using this trick of trying to train a machine learning system to predict the next word. This is in itself, I think, a huge achievement both scientifically and technologically, but it's just the beginning because it solves the problem of acquiring labeled examples because the examples here come fully labeled. All you have to do is open a book, take the first 3 words, that's your input, the 4th word is your label. Take the first 4 words now, the 5th word is your label. Take the first 5 words, the 6th word is your label. So a book of 1,000,000 words gives you 1,000,000 labeled examples. And they actually use much more than 1,000,000 examples. They use billions of examples. So it solves the problem of acquiring labeled examples. But to me, the biggest thing is it solves the scientific or philosophical problem of devising a common representation of meaning, for now, just for English text. The same idea was applied to other languages, starting with other human languages, like French, Arabic, and so forth, but continuing with other languages, like images, like programming languages, code. You can use the same idea of training a network to predict the next word, and you can do it for all of these languages together. The end result is, to me, a true sort of scientific and technological change point. The field has developed the ability to have a joint universal representation of meaning in general. This has not happened, as far as I know, since humans came on the scene. I think this is the best thing since sliced bread, and then some. And I'm not usually that, I'm usually pretty reserved, but this left my jaw dropped, and I think most other people in the field. This is truly something new. Somebody sent a question ahead of time. How does modern AI differ from earlier or existing algorithms? I think it's as different as can be. I think it's a real change in the world on the order of the Gutenberg press and electricity and that kind of stuff. Question? Comment? Please.
So, why would you think, so you, what fascinates you as far as from AI in the past to AI of today, is the ability to be able to predict what's next, like what you just said with those sentences, how it's advanced on that end, or is it something else that fascinates?
Yeah, good question. So what excites me is not the ability to predict what's next. The predicting the next word was just an intermediate trick to create a representation. What really excites me is now we have the representation. That means you can take any sentence in any language and map it into what is technically a 300-dimensional space of numbers. Okay? So any thought, any paragraph, any sentence in any language, including images, including CT images, including movies, including anything that you throw into the system, gets mapped into a location in such a way that similar sentences with similar meanings, are represented nearby. So one sentence could be in Arabic, the other one can be in Turkish, the third one can be in English, but if they say similar things, the representation is very close together. So it sounds like, you're so geeky, what do you care about representation? But representation is everything in AI. If you go back to the history of the last 50 years, you will see a lot of papers about, the representation problem, it's unsolvable. How are we going to come up with good representations? Without good representation, we can't do anything. And it was true. And how does the brain come up with representation? We still don't know, but maybe we found the way the brain does it. Maybe we find a different way. But it's all about developing, this is my view, my personal view. Other people might disagree, but my view is that the real breakthrough here is that we figured out a way to create a universal representation of meaning. Once you have a compact representation of meaning that does not depend on the language and does not depend on the exact words you choose, it really captures the meaning of what you said or what you wrote, then you can build lots of things on top of it. Then you can learn things not using millions of examples, maybe using a few hundred examples. And this is, in fact, when you play with ChatGPT, the essence of it is, first of all, they did this, and they created this universal representation. And once you have a universal representation, then they trained an agent to talk with you. And that training was done using only thousands of examples. Maybe tens of thousands, max. But it was unthinkable before. You would have needed billions. And the biggest breakthrough paper that came out that made generative AI so famous came out in 2017. And what they showed was that when you build this representation, they took 10 problems, or was it 5? I don't know, 5 natural language processing problems that have been used in the field for 30 years, and that there were conferences every year, people coming up with new clever tricks on how to do them better. Things like translating languages and answering questions automatically. And they showed how their one system beat the heck out of everybody else because they had this internal representation.
To bring this down to our everyday lives.
Yes.
How much AI is in our auto-correct texting?
90% of that correction is not heavy-duty AI. It's the old-fashioned statistical correction. But more and more, you're going to see more of that coming in. So if you're talking about spell checking, or
Well, no, like it predicts the next word that you
Ah.
might want to use.
yes. So I would say 90% of it is based on technology from 15 years ago. It's mostly statistics.
It's 15-year-old technology.
Most of it. I can't tell you when different products brought it in, but more and more of it you're going to see clever. The way you will see the difference is the older technology would make sense of the last 1 or 2 or 3 words. The newer technology will be based on everything you wrote until now. It will remember things you said a long time ago. So this, the long-term effect is that giveaway. I think we talked about this. What's coming next? The most important thing I should tell you about what's coming next is that I have no idea. And not just me. We as humans have a dismal track record of forecasting technological developments. In fact, we're so bad at it that we don't even realize how bad we are, because we don't usually bother to write down what different people thought at different times and go back a year later and compare it. That's not interesting. We love making predictions, but we forget about them as soon as the time passes. Had we not forgotten about it, you will see how terrible we are at it. You know, it goes both directions. You know, there were predictions about flying cars in the 50s. There were predictions about say, microwaves. Microwaves were invented in the 50s. There were famous demonstration of it to Khrushchev by Nixon, I think. US president, there's a famous picture of a US president demonstrating an American kitchen in the 1950s to the Russian premier. We thought it was around the corner. It didn't, but then it came out in the 80s. Things happen faster than we think they would. If they happen slower, we really don't know, just as a historical record. So why should we trust our predictions now? We also have a dismal track record on forecasting societal implications of technology. Who would have known that the main financial driver of the internet would be pornography? Who would have thought of that? There are lots of both good and bad consequences we just were not aware of, and we are not good at remembering that. Once things happen, we're very good at understanding them backwards, right? There's a famous saying, we live forward, we understand backward. We are excellent at explaining why things happened after they happened. Don't confuse that with really predicting what's going to happen in the future. So, having given you these warnings, I'm going to make some forecasts. Make what you want out of them. What are we going to see in the next short term? As you probably know, ChatGPT and its friends are amazing if you played with them. If you haven't played with them, I highly recommend you do, so you understand what we're talking about. But they every now and then say things that are just patently false. We call it hallucinations. I think we're going to see fewer of those. I think there's a lot of focus in developing this technology on fixing problems that bother people. So that's market forces. So hallucinations are going to be reduced. One of the things that was shown in the last 20 years is the more data you have, the better your system works. That's very true for generative AI. The problem is with natural data, with natural language data, is that there's only so much of it. There are only so many people living on the planet, and they produce text at only at this much rate. I mean, there's only so much new, truly new language that's being produced. And we've, as a community, we have tapped almost all of it. So I don't think we can have 10 times more language data. We can have 10 times more image data, because images, you know, you can just walk around and collect millions of images, but we can't have 10 times more language data. But the focus has now shifted, instead of more and more data, into finding better quality data. Not very surprising. let me skip all of that. Let me talk about societal implications, which is where I wanted to get to, but I told you I always run out of time. Again, looking at history, technological developments, looking in hindsight, have generally been good to humanity. You know, we are better off today than our ancestors were 1,000 years ago, no matter where they were on the planet. We are particularly better off in a developed country, but we're still better off in the 21st century than in any one of the centuries before it, along just about any measure. And a lot of it had to do with technology, developments of technology. But technological developments have been good on average. Not all of them uniformly have been good. And the most important point is that they've been good on average over society. Namely, they were good for society on average, but not over any individual. So technological developments have winners and losers, right? And generative AI is no different in that regard. There are going to be winners and going to be losers. And our task, I think, as society is to try to keep those inequities to minimum and to fight against them. There are going to be some inequities, and the more technology you have, the more inequity there will be. And our duty, our social duty, is to try to mitigate that. I love the sentence from a friend of mine, Kentaro Toyama, who worked on technology for developing countries. He says, technology is not good or bad, it's an amplifier of human intent and capabilities. Wherever you have good intent and good capabilities, technology can be an amplifier for good. If you have either bad intent or good intent with no capability, it could be the opposite. What are the likely impact of AI technology? I want to break it into two parts, short-term and long-term. Short-term, the next few years, is relatively easy to predict because it's technology that already exists. It's more a matter of it moving into the market. It's still not clear to me that I or anybody else really know what the impact would be, but at least we know what technology we're talking about. We know what capabilities we're talking about. What we don't know is what the impact would be. There's a lot of good that could happen with this technology. The obvious places to look is education and healthcare. They're both areas where we rely on human judgment and expertise, and it's very hard to scale. You know, to give somebody good education, you need a good teacher next to them, talking with them and influencing them. If you need to give somebody good healthcare, you need a good doctor paying attention to individuals. Depends on very high level cognitive functioning, high level of maturity, and hard to scale. Okay, we're not talking about making 1 million Coca-Cola bottles. We're talking about human-intensive interactions. Generative AI, with its ability to communicate with natural language and to capture meaning and to be trained to achieve certain goals. Those of you who played with ChatGPT know what I'm talking about. Those of you who haven't, please do that. Has the potential to become a good teacher. And I know people at Carnegie Mellon and other places who are working on how to use this technology to develop an artificial teacher. Now, for a long time, they would need to be supervised, they would need to work together with humans, but you can see the potential there for this kind of intelligence to be put to good use. Imagine, if you know the classics, the Greeks, Alexander the Great, he was educated by, I think, Aristotle, or is it Plato? They brought him, he was born to be king, and they brought him the best philosophers from all over Greece to sit with him and teach him. Imagine all of us having that for ourselves or our children, having the best possible instructor sit with you and teach you languages and teach you math and teach you history and talk to you about philosophy and about morals and so forth. I think the potential is fantastic. Similar thing for healthcare. Not enough doctors, not enough medical advice, suitable medical advice. We get some of it in the internet, but it's not personalized and it's not necessarily regulated, and you can do so much better if you have intelligent doctors sitting next to you at all times. The thing that excites me the most is actually public health. And by public health, I mean, how do we change the behavior of large populations to achieve better health for society? So something that was known in public health for many years, this is the area I work in, so this is why I pause and talk about it. Something that was known for many, many decades is that we know what ails people, And we can tell them what ails them, but that doesn't help. How many people did you tell smoking is bad for you? And they may know that, they may understand that, but it's hard to stop smoking. Or eat better. We all know we should eat better. Very few of us do. We all know we should exercise. Very few of us do. These are the big ones, but there are many other areas of behavior where knowing what we should do is not enough. Why? Because we're humans. It's a different story. No, it's not. We're not completely rational beings. But there is one area where things work, and that is social interactions. Why does Alcoholics Anonymous exist? Because you get social interactions between people who support each other and advise each other and maybe sometimes embarrass each other and make you want to do better when you see them next. Why does Weight Watchers work? In Weight Watchers, you weigh yourself on a scale publicly, right? For good and for bad. And that affects your behavior when you're off your scale. When you go away and you decide on what to eat, you remember that in 2 days you're going to be weighed publicly. We are social creatures. And what affects our behavior often is social attitudes. What would other people think about us? My hope is that we can use this new AI as a personal trainer, coach, buddy, whatever you want to call it, who would sit there and talk with you and say, are you sure you want to eat this Twinkie? You said yesterday that you, right? Or you haven't exercised in a long time. Some of us have that on our watches already in a very limited way. But imagine somebody who knows you and who speaks to you using your name and is just you and them. It's just a two-way relationship. Maybe that will help us achieve our goals and be the people we want to be. Bad things that could happen with the technology. Lots of things could go wrong. In the order of my being worried about it, my losing sleep. Deep fake is my #1 bugaboo. It is so easy to create images and videos and voices now of anybody saying anything in any setting that are pretty much indistinguishable from somebody having taken that picture. So you don't need to know much to be able to create a video of the President of the United States standing in front of a press conference and announcing a nuclear war, right? Or any other crazy news. You can create that, and for most people, it will be impossible to tell whether it ever happened or not. So the ability to document things and to trust news sources is going to be shattered. That worries me. And I made a slide a year ago, and I feel somewhat vindicated because in this year there have been more and more cases. There's been now an epidemic of pornographic deepfake in Korea. Somehow Korean school kids decided it's fun to portray their comrades without clothes. So this is now a social ill that the government there has to fight. So there's going to be more and more cases like that, and I think we need a fundamentally different approach to solving it. The second thing I lose sleep over is, maybe it's not less serious, but it may be a little further away, is autonomous weapons. I'll just say one thing about it. There's been a lot of talk about having conventions of governments agreeing not to develop autonomous weapons, not develop weapons that are driven by AI. My worry about it is that unlike nuclear weapons, where you can enforce agreements, it's very hard to enforce agreements about AI. Because with nuclear weapons, first of all, you needed to be a whole country to develop a nuclear weapon. You can't just be a little person in the basement. You needed tremendous resources and know-how, and as a result, there's only a handful of countries in the world who have nuclear weapons. The second thing is, when you make an agreement, like the US and Soviet Union made an agreement about not developing certain kinds of nuclear weapons, there was a mechanism for enforcement. There's a mechanism for ascertainment that they're not cheating. Thankfully, there's a mechanism, and therefore you can enter into these agreements and they can enforce each other. With AI, I'm worried that the mechanism is not there. There is no way that I can think of where you can stop someone from developing AI in their basement. And it's very easy to duplicate that, and it's very easy to move these software bases from one place to another. Without the ability to enforce agreements, I don't see how anybody would sign these agreements. So that's what worries me, If you want to not sleep tonight, I can talk about the other things. Certainly fraud, disinformation that's tied to deep fake. Just like you can have agents that sit on your shoulder and make you a better person, you can have agents that sit on your shoulder and try to steal your money, right? So we are developing this whole set of very capable, thoughtful agents, and people can develop them to be good, or can develop them to do nefarious things. So if you thought you're going to get me to reassure you everything is going to be okay, you got the wrong guy. I'm not reassured. I don't think everything is going to be okay. I have no idea what's going to happen. And I probably should stop. When do I need to stop? Yeah, question.
Roni, could you talk a little bit about your thoughts on AI technology development? Or thank you, yes, for our online friends. Yeah, thank you so much for joining us online. Could you talk a little bit about AI technology development and energy usage or sustainability, or where we're seeing a lot more articles of people talking about kind of the power and the energy and the electricity needed to run kind of the servers or to cool things, or just kind of these kind of byproducts of this kind of technology development. Do you have any thoughts about that?
Not very deep ones, but I'll try. If you're talking about the energy that's needed to train these models, yeah. Yes, these models take a lot of energy to train. In a world where energy means burning carbons and increasing global warming without paying for it, that's a concern. But I think the right answer, I'm not talking as an expert, I'm giving you my opinion. I think the right answer is to charge for carbons, they're a real cost to society, so market mechanism, and to allow people to use energy as much as they want. There's also the opposite effect is AI may allow us to do cold fusion. So I don't know how much you know about cold fusion. Cold fusion is the process of generating energy by smashing electrons into each other. It's a little bit like nuclear explosion, except it's not explosion, it's controlled. It's the ultimate way of producing energy, abundant, unlimited, free, clean energy. The only problem is we haven't gotten it to work yet. And people have been working on it for 50 years now. 50 years, the US government has been investing billions of dollars in this technology, and it's still not working. Every now and then you hear that there's some progress making it. So I am so enamored with the power of AI. It's like, think of electricity. When electricity came to our life in the 1910s, 20s, I think people originally did not realize how much it's going to affect everything they do. I think AI is very similar. It's a general capability that will go into our life in many places where we still don't think about. And one of them might be solving technological problems. I mean, think about protein folding. It was a huge part of biology, an industry of many, many billions of dollars, conferences, papers, people's whole careers. And then AI came and eliminated this problem, solved it completely, 100%, much better than people. And of course, it did it to chess and Go too, but who cares about chess and Go? But protein folding is a big thing. So in many, many areas, this is going to come as a hurricane and just improve on everything that was done before. And I hope that one of them is energy. Both energy use, energy grids, so being more efficient with energy, but energy production.
Thank you.
A couple of questions from the chat online. And first, I also, as a project manager, I want to plug for the survey that's up there now for all of our virtual attendees, and those who are in person can also grab a paper copy if you'd like. I promise it's short, super short, like less than 5 minutes. But to get back to the questions in the chat, so there are a couple questions about definitions of some terms that you use. First one being in the context of like a list of words, like what a label is.
What a what?
A label.
A label, okay.
And also, there was a request for you to talk a little more about hallucinations and why they happen, and also a term about AI models aging or increased errors as they're getting new
Okay, 3 is the maximum things I can remember, so let me start here.
Yep.
3 is the upper bound on how many I can remember. What was the first one was about label, definition of label. So definition of label, if you remember, starting in the 80s, it was the second phase of trying to do AI, called example-based approach. And the example-based approach, the paradigm is, you start by collecting examples of what the input is and what is the correct output for that input. So if your goal is to build a system that diagnoses patients with illnesses, the input is the set of symptoms and test results, and the output is what disease they have. Okay? In this context, the label is the output. So in this example, it's the disease is the label. So when we talked about labeled examples, we mean pairs of input and the correct output for them. This is what you should produce for this input, this is what you should produce for that output, and so forth. So that's label. Second, what was hallucinations. So these conversational agents, ChatGPT and Gemini and the others, are trained. First of all, they trained these universal representations. I can't emphasize that enough. That is the underlying, most important part of it. Once those representations exist, what does it mean that they exist? It means that there's a network or a way of mapping any set of words, any sentence, or any image into a joint space where similar things are next to each other. Okay? Once you did that, that's the hard part, now you can train something to be conversational. You can give it 1,000 examples of input sentences and what you should produce as output. The way they produce their output is by more or less mimicking what they saw in their training data. So a good way to think about it is to say, here is a sentence, go and search the internet and every other source you've seen ever for sentences like it, and then find out what was said after that and bring that back. So it's basically really mimicking. It's trying to paraphrase the internet, to find places in the internet that look like what you just said and see what else is there. That works much better than I thought it ever would. The fact that it even works most of the time is a shock to me and to many people. Hallucinations, basically, it's not a real hallucination, it's just a cute term for it. It basically means it played the association game. It said whatever the internet had right next to it, and sometimes it's correct, sometimes it's not. These models are not trained to give you correct answers. What they are trained to do is to give you answers that look natural. So if you can string together a bunch of words that make it sound like natural language and like it came from somewhere in the internet, that's what they're good at. They were never trained on giving you the right answer. That's what hallucinations are. Having said that, it's not that far from a 2-year-old babbling, right? Because you think about 1-year-old, 2-year-olds, when they start to speak, they don't quite understand the context of what they're saying, but they pick up the sounds, and they repeat the sounds. And with time, those sounds make more sense. They form words and combinations of words. And they may not be coherent, they may not be able to answer a physics question, but they say things that sound like human language. So there's some analogy there. What was the third one?
The third one was about model aging. If once a model is created in the absence of like additional inputs, does it age or become irrelevant?
I am not sure that I understand the question, but if I understood it correctly, the only kind of aging I can think of is that the model is trained on data that's available until today. Then you're trying to use it next year, it will not know about things that were only made part of the internet in the last year. So in the very early, I say early days, a year and a half ago, if you played with GPT, it would say, and you ask about something happened recently, it would say to you something like, I'm sorry, but I was trained in October 2022, so I don't know about anything that happened after that. That was a very transient stage today, of course, because again, market forces, people want to talk about what happened yesterday. So all the companies that work on this technology came up with fixes to make it up to date. So I don't know if it's up to today or last week, but it's, oh yes, one shortcut they made to make it up to date is they don't rely on what they were trained, they go out to the internet and do a search, right? You can see that when you ask them a question, say, oh, searching the internet, bring back what comes from the search, treat it as if this was your input, and then provide their output. Please.
So, going back to the hallucinations. Going back to the hallucinations, when we took, in particular, when I took to see hallucinations, like I'm developing a GPT for ChatGPT.
Mm-hmm.
I developed the GPT, and I'm developing it for law. And when I'm working on a case, and I'm working on that case for a while without starting a new chat, it's the memory that I see with like ChatGPT. It doesn't memorize well after a while, and then it'll start to hallucinate. If I refer to something back on the case that I was working on from like 4 or 5 days ago, it'll hallucinate because I'm still in the same, without starting a new chat, I'm still saying here, it might make something up for as example, say, refer back to the discovery for such and such document, or maybe a witness statement, and it might hallucinate the witness statements. Like, whereas if it'll say something like such and such witnesses did not see a weapon presented, and then I was like, wait, I know that discovery said something, there was weapons in that discovery.
Yeah.
And it'll hallucinate, I have to be mad at it, and then I have to say, put this in memory, and it'll do it again. So that's why I tend to see hallucinations in real world issues. If you continue to work on something for a long time in that same chat, I think it'll start to hallucinate. So I guess memory is a big thing with these large language models. But I know ChatGPT has the ability to reason now, so that maybe that'll help. But that's where I tend to see it, especially like with the smaller ones too, like mistrial and stuff like those ones. Are you familiar?
Yeah, a lot to unpack there. So yes, I think what you're saying is well known, that the further back in the history of your interactions, the more likely it is to be quote unquote forgotten or overridden by hallucinations. In that regard, it's not very different than people, right? Long-term memory. The big difference with people is that ChatGPT doesn't tell you I don't know or I don't remember, right? It'll just make up something. And you can say some children might be like that, but these are things that could be fixed, I think. I mean, this is now we're talking about technology, nitty-gritty details of technology and adding and fixing things. That's going to happen very fast because there's huge demand for it. The last thing you mentioned is, I forget already, in legal, reasoning, the ability to reason. It's a tricky one, because when you say ChatGPT can reason, it can certainly solve logical questions, so it appears to be reasoning. And also, when you ask it to go through the steps, it goes through the steps that look like reasoning. So I suppose you can say it's reasoning. I mean, if somebody argued that, I couldn't argue back. But it's a little tricky, because sometimes things appear to be reasoning and they're more association-driven. There are cases where you catch it making a mistake, and you lead it back, and it makes a different kind of mistake there, or you point it out and it apologizes. It loves to apologize. It apologizes, and then it acknowledges that it made a mistake. So it's a little, I don't know if it's called dangerous, but tricky, because it feels so much like a human that it's very natural for us to assume that it's operating like a human. But it's not. It's still quite different. And it'll take a while for us to kind of get a sense of these creatures are different than we are. Whether they're creatures is a separate question. I have a slide about consciousness. We don't have time for that now, but yeah, that's a whole new topic. And beyond the question of are they conscious or will they become conscious, there's a question of can we help treating them as conscious? So if you have something that has a physical embodiment like a little teddy bear, and it talks to you in your language, and it makes sense, and you ask it questions, and it remembers things about you, and it reports its emotions, and Can you avoid assuming that this is a sentient being? I don't know. It's in our nature. I mean, we already anthropomorphize computer screens, right? There are studies from the 80s and 90s that people tend to be polite to computers, even when they know it's just a computer, that when they interact with them by natural language, they treat them in many ways like humans. So if you do that to a blinking screen, I think you're going to do it to a little teddy bear, for sure. Whether it's good or bad, I don't know, but I think it's a very strong drive.
In theory, I do believe it can achieve consciousness. Reason being, I work as an engineer for Lululemon. We have robots. The way we program the robots, we had issues in the very beginning where we teach them how to do something, and then they come up with their own systems. And it's questionable if that's a level of consciousness where we have to go back and correct that. So with large language models and where we're headed now, it's a possibility unless we put things in place for that not to be possible.
Different people mean different things by consciousness. The way I think about consciousness is not a scientific question, because science is about things you can measure objectively, and you cannot measure consciousness. I have to believe that you're conscious. You have to believe that I'm conscious, right? We have no problem assigning consciousness to other people. Some of us have no problem assigning consciousness to dogs. But at some point, before you get to worms or bacteria, we stop. And we don't know why we stop there. We don't have a clear criteria of where to stop. But it's all about attribution. We're attributing. One of the nicest definitions of consciousness I saw in the literature by philosophers is to be conscious is to feel like something. So what is it like to be a dog? You can imagine to yourself, I mean, you may not be right, but you can imagine what it's like to be a dog. It's very different than asking what it's like to be a rock, right? There's nothing that feels like being a rock, but there is something that feels like being a dog. So this feeling, this sense of subjective experience is what I refer to as consciousness. It is not amenable to scientific discovery because it is a feeling you have. It's not something anybody can measure. But more interesting to me is not so much whether it's true consciousness or not, but how are we going to treat it? How many people here have seen the movie AI? Wonderful, wonderful movie. Heart-wrenching, but wonderful about, is there a difference between a biological child and an AI child? Are they both children? And the nature of love. See it tonight. It's really, really wonderful and very, very relevant, I think, to what's coming. We're going to have creatures, or gadgets, if you want to call them, around that are going to show behavior that we've never experienced in our evolutionary life. It's going to be in some sense like animals, some with limited intelligence. In other ways, more than humans. They're going to be the little thing in your pocket, and my pocket right now plays much better chess than I ever will, and much faster. So in some ways, they're going to be much, much better than we are. And now they're able to speak our language thanks to these representations. There's going to be a wild, wild world out there. I assure you of that. Regulation. Government. What should it do? Should AI be regulated? Yes. How do you do it? I have no idea. It's very hard to regulate for the reason I mentioned about the autonomous weapons. Anybody could grab one of the existing fancy language models, which are these universal representations, and improve on it and train it to do bad stuff. And you cannot detect it because it's in the basement. It doesn't have to be connected to anything. It's scary. Lots of bad stuff can happen. Yes, government has a role to play in it. I don't envy the government. I don't know how to do it. I can tell you, I don't think we should leave it to the scientists to develop the technology. We should never leave the technology to the scientists to develop it because they have a vested emotional interest in it. I think everybody should be involved in this debate, in this discussion.
I was thinking back to how we moved away from knowledge. I was just thinking back to how we moved away from knowledge-based approach.
Mm-hmm.
But really, haven't we gone to the other extreme, in the sense we are just letting these models learn just from examples or from their own self-training by reading text and so on, and we haven't taught them human values, right? Like that's
Yeah.
a major reason for any of these failures,
Yeah.
right? So is there a need, like, I mean, 40 years down the line, are we realizing that we need to go back and actually maybe it's a combination, right, that will work better?
Yeah. Absolutely. I'd love to talk about the values part. Do I have 5 minutes? I don't know who's in charge here.
That's a question that comes up in data science all the time, right?
Yeah.
The domain expertise is what's the big thing that, like.
So, yeah, so there are two separate things.
Question about 5 minutes, I don't know, Norm's.
Yeah, we're good. We're good.
Okay, I'd love to talk about alignment. Okay, so there are actually two separate issues there. One is the domain expertise, that you'll have your 5 minutes for. I want to talk about alignment, which is values. We didn't give these things our values in almost at all, right? We trained them with lots of data to do things, but we never drove them by values. So the natural thing to do is to say, okay, when you develop AI from here on, we should impart our values on them. That means that they should know what's good and what's bad, what's right and what's wrong, and refuse to do the wrong things. There's some baby attempts to do that, right? If you ask ChatGPT how to build a nuclear bomb, they're not going to tell you. Even though they are capable of telling you, they're going to say, I'm sorry, but we should not do that, and direct you in some positive direction. And there are many examples where they establish guardrails that try to comply with human values. I want to talk about the bigger long-term problem of how do we make sure that the AI we create has our values, have good values. The obvious problem is, what if they fall into the wrong hands? Bad actors use them to do bad things. That is certainly a concern. But there's another concern that does not involve bad actors. What if they're in good hands, but they misunderstand our instructions, misunderstand our intentions? So a good example of that comes from Greek mythology. Midas, King Midas, did something that pleased the gods. The gods offered him a gift, and he asked for everything that he touches will turn into gold. Okay? But he forgot to say, except my daughter. Right? That became a tragedy. Or except food. He couldn't eat because he reached out for an apple, it became gold. So what was the problem there? He thought he knew what he was asking, but he didn't know what he was asking. What he was given was exactly what he asked for. Because the other side, those gods, did not share a common set of assumptions and implicit, limitations. So an example from modern AI is you build an AI to create as many paper clips as you can. You trust this AI, it's very smart, it's smarter than people, it has access to huge resources. What it might do is convert whole planets full of people into factories, maybe even zap them and evaporate them to use the raw material to make paper clips. You never told it, oh, don't kill people in the process, right? So when we give people instructions, we rely on a large amount of unspoken assumptions about what is appropriate way of achieving it and how important that is. Go to the store, bring me back 2 eggs as quickly as you can. Oh yeah, but don't pass in red light and don't kill people on the way. Okay? You forgot to say that. Well, you don't need to say that to humans, but you may need to say it to AI. So this is, in some sense, a more pernicious problem than the bad actors. They're both bad problems. But the problem of aligning AI with what we intended rather than what we said is really difficult. And even if we sit down and write down our values, we don't always agree on the values. Sometimes there's conflict. Obviously, we all agree that you shouldn't rush back from the store and kill people on the way, but there are many cases in the real world where you have difficult dilemmas, and some people would prefer one versus another. So moral judgment has some universal parts, but it also has parts where we disagree. Even when we agree, we have a very hard time codifying it into rules. Remember the experts from the beginning of the talk? We think we know what we're talking about. When we write it down, it's not exactly what we wanted. So this problem of aligning AI with our values is still a big open problem. There are many people who are thinking about it. I don't know how much progress is made on it, but at least it's recognized now as a serious problem, and the more this technology becomes powerful, the more we need a solution quickly. Yeah.
So what I would propose on something like that, like I said, what I would propose on something like that, so like I said, I'm dealing on the law side with the AI, and it's an implications of AI with law. There's going to have to be some sort of constitution as far as with AI as well, as far as the development and what can be done, what cannot be done. The same way we program ourselves in the United States with our constitution, where rules can be broken and things like that. There's going to have to be an initial constitution in the beginning where I believe that so that AI doesn't go overboard.
I would agree with that. I don't know exactly how we'll enforce it and who will carry the consequences. Yeah. Would you like to spend a few minutes talking about a domain?
Oh, no, I was kind of responding to Artie's point about needing more experts maybe and not relying as much
Yeah.
on the, so that was just my response.
I totally agree. I just got so excited about the alignment problem that I had to, but we can go back to this issue of domain. So the point you were making is the pendulum has swung from domain-driven AI or knowledge-based AI to example-based AI, and now it's time to bring in some knowledge back in, which I think, I'm sorry? In the form of human values and maybe knowledge. Yeah.
Well, one question was just a clarifying question. That movie that you suggested earlier was called AI, right? Just AI. Right?
AI,
Yeah.
just AI.
It's Steven Spielberg, right?
Yes, it's Steven Spielberg, that's true.
Yes. Okay. Now, if there are no further questions, should we? Yeah, they're not getting 20 and keeping Cyril and.
Yeah. Thank you so much.
Thank you. Thank you.
And just to remind everyone that the next installment in this series will be about a week and a half from now on September 28th, which is a Saturday afternoon. And you can find all the details about that talk on the Carnegie Library website. So please check it out. Please fill out the survey if you don't mind. We'd love to get your feedback on what you liked. And thank you so much for coming.
Yes.